We all have been depending on the use of our technologies just to make life easier for us, mostly now that we are living in an era that fully relies on technologies. Energy is defined as the ability to do work, and it can be found with almost everything that even us humans use. There are two types of natural energy resources: the renewable and the non-renewable energy. Non-renewable energy has a limited supply of resources, while renewable energy can be replenished. Today, in this video, we will discuss the renewable energy and its types, which are the solar energy, hydro energy, wind energy, biomass, and geothermal. Solar energy is an energy that is produced by the sun. We had been using solar energy for thousands of years in many ways by people around the world. It is also the most durable, improving, convenient, and affordable source of electricity. It can be converted into electricity by the use of solar panels, net meters, and inverters. Photovoltaic cells are set up on rooftops to accumulate the amounts of sunlight directly, which transforms solar energy into electricity by the use of the sun's energy. Solar energy capacity in the Philippines has grown exponentially 2 megawatts in the year 2011 and 1,048 megawatts in the year 2020.
It is the most advanced and mature among the 5 renewable energy resources. It is capable of generating enough energy for a vast amount of countries across the world, having advantages in terms of reduced greenhouse effects and cheaper operational costs, making it a renewable energy become reusable for electricity generation. A large amount of water in rivers, streams, lakes, and waterfalls are channeled from water turbines before being dammed inside water dams. It generally starts with water flowing in the dam's turbines, and then a rotating shaft drives an electrical generator which converts the motion into electrical energy while regulating the flow through penstock thanks to the pressure of the water to the turbine blades. Hydro energy is regarded as one of the most cost-effective energy sources. Installations of hydroelectric power plants harnessing the power of flowing water would be basically cost-friendly. Renewable energy capacity worldwide include and exclude hydropower from 2008 to 2020 at 2.8 terawatts. Renewable electricity generation includes large hydropower as a share of total generation from 2000 to 2018 with 26.3% of production.
Wind energy is no different from other forms of renewable energy with respect to the mitigation of the artificial, systemic, and environmental destruction that human activity and lifestyle constantly causes. In fact, the use of wind turbines to harness it may even dominate the arena due to its lack of pollutant emissions. Additionally, these vertical cylindrically based machines occupy small areas, having limited physical footprints. Groups of these are called wind farms, and they may be found in open land, mountain ridges, and amidst bodies of water. It is easy to see how these may negatively affect our surroundings just as it helps it. It could visually obstruct landscapes, be sources of fire, cause unwanted noise, kill aerial animals, require supplementary infrastructure, and have financially and environmentally costly manufacturing procedures. However, we must remember that these drawbacks are heavily outweighed by the fact that turbines are literally giant fans that draw energy out of thin air. The internal mechanism of turbines consists of all of this. It's obvious that it needed clever engineering, and this is rightly so. A myriad of factors had to be accounted for. Namely, some of them were topography, the speed and direction of the wind, the pitch, yaw, shape, size, and surface area of the propeller, and a bunch of others. A power curve is typically utilized by complex system controls attached to the machines to make appropriate minute adjustments that constantly depend on volatile winds. To maximize energy yields, the tip-speed ratio must be optimized through this formula. Here are experimental tachometer readings.
Geothermal energy. The word geothermal came from the Greek words geo, referring to earth, and therm, referring to heat. It originates from the heat generated from the radioactive decay of materials found in the center of the earth. Geothermal energy is generated by pumping water deep into the ground, where heat deep inside the earth converts it into steam to make electricity. When water reaches the surface, the pressure drops, causing the water to turn into steam. The steam spins a turbine which is connected to a generator that produces energy. When the steam cools off in the cooling tower, it turns back into water, repeating the process. The Philippines is rich in geothermal resources because it is situated in the Pacific Ring of Fire, where there is lots of geothermal heat. The Philippines is one of the leading countries in geothermal production. As of 2020, the Philippines installed geothermal energy capacity is estimated to be 1,918 megawatts out of the global geothermal installed capacity of 15,608, ranking third globally. The country can potentially generate 2.1 gigawatts of geothermal energy in 2025.
Since the earliest of days, cavemen had been already using biomass energy for cooking and source of heat. It can be either a plant or an animal, living and non-living organisms that can be used to produce electricity. Biomass is an integral part of the Earth's carbon cycle, a process where carbon is exchanged between all four layers of the Earth, which is the lithosphere, hydrosphere, biosphere, and atmosphere. Carbon helps regulate the amount of sunlight that enters the Earth and is exchanged through decomposition, photosynthesis, respiration, and human activity. A steady supply of trees and plants are vital in maintaining a healthy environment. There are four conversions in biomass. Thermal conversion involves heating the biomass feedstock to generate fuel. Chemical conversion is a process known as transesterification that converts vegetable oils, animal fats, and grease to produce biodiesel. Biochemical conversion involves the use of bacteria, microorganisms, enzymes, and microbes to break down into liquids and gaseous feedstocks that can be converted into biogas or bioethanol. Electrochemical conversion is the oxidation of material that can be performed directly and indirectly to become fuel cells.
Overall, this report proves the benefits that renewable energy can provide to the public and the upcoming generations. From solar energy's capabilities, hydro energy's availability, geothermal's heat, wind energy's convenient usage, to biomass's carbon cycle process. Although as of right now, it is still hard to fully switch to renewable energy because of how cheap and flexible fossil fuels can be for energy production to manufacturing, it is still a safe bet on renewable energy because it is very reliable and pollution-free. It can change the whole perspective of humankind when it comes to electricity and power. Again, everything gets better and better in relationship with the ecosystem, and renewable energy is proof of that.